put together an interactive simulation on a scope and signal generator that I think you might find useful, and it's available at this website. I was just going to quickly run through a demonstration of the simulation in action. So what we have at the top here is the waveform that's been produced by the signal generator at its output. And we can change the shape of the waveform that's been produced by changing these buttons. So we have a rectangular waveform, a triangular waveform, and a sinusoidal waveform. And we can adjust things like the amplitude by controlling this dial. And we can see that the changes are being reflected up in the waveform above. We have control over the DC offset as well as fine-tune control of the frequency using this dial. If you want more significant changes in frequencies, you can use one of these buttons. What we're seeing on the scope's display is basically a snapshot of the waveform that's been produced by the signal generator that's taken at regular time intervals. You can see that the scope display is made up of a grid which has 10 horizontal boxes and 8 vertical boxes. And the resolution of those boxes is controlled using these dials. So at the moment the vertical resolution, or the volts per division, is set to 1 volt per division. And if we look at this waveform that's being produced, we can see that its amplitude is roughly 2 boxes, which means that its amplitude is roughly about 2 volts, which we can also see up here. If I change the number of volts per division, it's like we're zooming out of the waveform, but we can see that the waveform still occupies 1 box, but that corresponds to 2 volts per box, so it's still a 2 volt waveform. We can change the time resolution using this dial. So at the moment it's set to be 0.2 seconds, which basically means that we have 10 boxes at 0.2 seconds per box, which means we have 2 seconds of a waveform being produced on the scope's display. If I change the dial position, we now have 1 second, because it's 0.1 by 10 boxes will give us 1 second of the waveform that's been produced by the signal generator. Now we can see that the waveform is kind of jumping all over the place. That basically means that the waveform isn't being triggered. So what I'm going to do now is trigger the waveform by adjusting this trigger level. And when the waveform is triggered, you can see that it appears to be stationary. I'm just going to adjust the frequency because sometimes it loses trigger if the frequency isn't high enough. And basically what we're doing when we're triggering is we're taking a snapshot of the waveform, but we're imposing an additional constraint. We're making sure that the voltage reaches a particular level at a particular time so that the waveform will appear to be stationary. So what's happening is every time we take a snapshot of the waveform that's been outputted by the signal generator, we're making sure that the voltage reaches a particular level, and that level is set by the trigger level dial, which is shown by this blue line. And we can see that every time the waveform snapshot is taken, the voltage of the waveform reaches this level at this particular time. So this arrow dictates the trigger time. Now we're triggering at the moment at what's called the falling edge. So the voltage is going from a high to a low voltage. We can change that edge by flicking this switch. So it's now going to switch to a triggering on a rising edge. So now what's happening is that every time we take a snapshot of the waveform that's been outputted by the signal generator, the voltage reaches this level at this particular time, now on a rising edge. You can adjust the trigger level, and basically what you're doing now is you're just ensuring that the snapshot is such that the waveform reaches a lower level at a particular time. But the waveform just appears to be stationary. It isn't really. If I adjust the amplitude, we can see that the amplitude has been reflected on the scope. Okay. That's the end of the demo. I hope you find the interactive simulation useful.